You can do the same thing with two cube terms. So consider the following two terms, 27x cubed and 8. In previous examples, we have shown that both are cubes. 8 is a cube number because 8 equals 2 times 2 times 2, or 2 cubed. 27x cubed is a cube number because it equals 3x times 3x times 3x, or 3x cubed. So both are cube numbers. So you have two terms. They're not like terms, so they can't be kind of smooshed into one term. So you can add them or subtract them to form a binomial. All right. So let's add them. And then because they're both cubes, the binomial you're going to be formed to have special names. So let's add them first. Let's do 27x cubed plus 8. 27x cubed is a cube term. 8 is a cube term, and you're summing them up, or you're adding them. So this binomial, right? Binomial just means two terms. 27x cubed plus 8 is called a sum of cubes. All right, we can do the same thing with subtracting. You can write 27x cubed minus 8. 27x cubed is a cube term. 8 is a cube term. You're finding their difference. So 27x cubed minus 8 is a difference of cubes. Now, because subtraction is not commutative, you can actually use these two terms to produce a different binomial. You can write 8 minus 27x cubed. So you have 8 is a cube term, 27x cubed is a cube term, and you're finding their difference. So both of these would be examples of difference of cubes. And again, how did I come up with these? This is just a learning environment, right? So I'm just producing this to illustrate a point. All right, so problem 2, identify each binomial as sum of cubes or difference of cubes. And then we want to convince ourselves and whoever is reading it this. So we're going to justify our answer. All right, example A, x cubed plus 64. All right, x cubed is a cube term because I can write it as x times x times x, or x cubed. So that's a cube term. 64 is a cube term because I can write it as 4 times 4 times 4, or 4 cubed. And the two terms are being added or summed up. So I have a cube term plus a cube term, so it's a sum of cubes binomial. X cubed plus 64 is a sum of cubes binomial. All right, part B, 8x cubed minus 27. So 8x cubed I can write as 2x times 2x times 2x, or 2x cubed. So it's a cube term. 27 I can write as 3 times 3 times 3, or 3 cubed. So it's also a cube term. And the difference between the two terms, 8x cubed minus 27, cube term minus cube term. So this 8x cubed minus 27 is a difference of cubes binomial. Okay. Part C, 1,000 minus x cubed. 1,000 is a cube term because I can write it as 10 times 10 times 10, or 10 cubed. X cubed is a cube term because I can write it as x times x times x, or x cubed. And you're finding the difference of the two terms. So 1,000 minus x cubed is a difference of cubes binomial. All right. All right, so those are actually 4 special types of binomials, right? Sum of squares, difference of squares, sum of cubes, difference of cubes. So what I'm going to do on the next slide is just summarize the results of problem 1 and 2. So if you want to glance at this slide or this screenshot to a reference. So here's all the binomials mentioned in the last 2 examples. So x squared plus 100 we said was a sum of squares. And the shorthand justification for why it's a sum of squares, if you don't want to write out everything we wrote out, you can write it's x squared plus 10 squared, right? And then it's plus, so you have a sum of squares. 4x squared minus 9 is a difference of squares, and the justification it would be it's 2x squared minus 3 squared. 36 minus x squared is a difference of squares, so it would be 6 squared minus x squared. Right, x cubed plus 64 is a sum of cubes because you can write it as x cubed plus 4 cubed. As sum of cubes, of 2 terms cubed. 8x cubed minus 27 is a difference of cubes because you can write it as 2x cubed minus 3 cubed. And 1,000 minus x cubed is a difference of cubes because you can write it as 10 cubed minus x cubed. Okay. So again, I went through these a little bit fast because we did already do them in a lot more detail, but it is actually helpful to write them in this form for our purposes later on, all right? So your homework is going to look like this table. I'm going to give you binomials. I'm going to ask you to identify the special type of binomials as one of the four and kind of justify your result here. All right. Okay, so I'm going to kind of press pause on this topic for now. The next topic we're going to go is going to be something a little bit different. So kind of like too many lessons in one lesson. All right, so the next topic, we're going to review the mathematical kind of verb or a directive to factor something out. We're going to review what it is. This is the one that shows up a lot, okay? A lot in algebra once you move on. So we need to understand what it is, otherwise it's going to be a handicap. So it's kind of like trying to do arithmetic without knowing what add two numbers means. Factor out is just a command or a mathematical verb, and I'm going to explain what it means. It's used a lot. All right, so before I do that, I'm going to remind you in the past when you learned a new kind of mathematical operation or a term. Remember, in earlier grades, you learned that distribute actually means to multiply, right? But it's to multiply one thing by many things. So maybe distribute doesn't sound too much like a mathematical term, but you learned that it's a command meant to tell you to multiply. So if you're asked to distribute 2x to x squared minus 10, right? You're distributing one thing to another. That's the language used. You know to multiply. So 2x distributed to x squared minus 10, you know to write 2x times, because you're multiplying by the whole x squared minus 10, you're going to put parentheses around it, and that's equals to 2x times x squared is 2x cubed, 2x minus 10 is minus 10x, so you distribute it. So the operation we performed from the left side to the right side of the equation, we distributed 2x. All right. Well, when you're asked to factor something out, you are actually being asked to do the distribution in reverse. So if distribution means to multiply, to factor something out means to divide. So the opposite or the reverse, not the opposite, rather the reverse. The reverse of distributing is factoring something out. And I'm going to show you how to do it in a moment. But first I want to show you what it looks like, the final product looks like. So if you're asked, by the way, this is the language, you will be asked to factor out 2x from 2x cubed minus 20x. So you will be asked to factor out one thing from another, and you'll know to divide. So if you're asked to factor out 2x from 2x cubed minus 20x, you'll write, this is what, I'll tell you how to factor out on the next example, but this is what the result will look like. The result will say 2x cubed minus 20x equals 2x times the quantity x squared minus 10. So you're basically doing the reverse of this. And if going from blue to green, we said was called distributing, going from green to blue or factoring out 2x is called factoring out, right? Factoring out 2x. Notice that the rest of it is in parentheses. Okay. So I'm going to explain to you how to do it, but this is what kind of an overview of the difference between distributing and factoring out. All right, let's go over the steps of how to actually factor a term out of something.